welcome back. This is Connor over here.
Hi.
This is my cadet. So he's going to assist me. He's helping hold R2. As you can see, we've got him off of the stand, and so he's very easy to pivot at this point. And so we got to kind of hold on to him a little bit. Otherwise, he's going to take off on us, and then we'll have premature droid repairs. All right, Connor. So what we're going to do is we're going to tip R2's base this way. Okay. You just hold it just like that. Okay.
Okay.
You got it?
I think I do. It's kind of hard to hold one leg in the base.
It's okay. You're doing good. Stand up straight. Keep it straight. Bring this one back. All right.
All right.
All right. Let it down just a little bit.
Here.
Right there. Okay. Hold it. Okay. And socket. Got him? Alright?
Yeah.
Okay, now come to this side.
Okay.
Alright? Same thing. Okay? Just hold them straight. Hold up straight. I'm going to move this leg. Alright, so what we're doing is we're tightening up these bolts on the side. So it pushes that washer in, and then we're literally going just about a quarter turn to a half turn back. Just give that washer a little bit of wiggle room. Alright, go ahead and stand back up. Okay. So we're all attached. Let's make sure he's still level. Left right's still good. Left right's still good. Just match it a little bit front and back. Okay. Alright, you got him? Okay. Just hold onto that leg. Let's see. You don't have to hold too hard. That's what it would look like in three-leg mode. Pretty cool. See how easy that is? Okay. Now we're going to keep hold on to him. Because he's not hooked into it with his yoke yet, he's still going to move. Alright, welcome back. As you can see, Connor's still standing here helping to hold this. We haven't done anything else to R2. Now, one thing that we did do is we did take off the COM-8 top plate that goes across the top right here. The reason we did that is it's easier to go work up and down without this plate because it's directly over where we need to work. So temporarily remove that. Make sure you store your screws. I keep them in a little plastic container. That way I don't lose them on the workbench with all the other parts. Now, one of the things we did, this is the yoke. This tab side goes on the left-hand side because that's where the limit switches are at. Alright, before you do that, you want to make sure you test the 4 U-bolts that Kevin sent. You want to make sure that they can go through with ease. Mine were a little tight, so I used a 5/16 drill bit, and all we did is just went through real quick, just cleaned up the hole, made sure it was nice and clean, and made it easy to get all 4 of these U-bolts through. Now the other thing with these U-bolts is Kevin sends them with 2 washers and 4 nuts. You actually only need 2 of these nuts, so go ahead and take 2 off of each of the U-bolts, slide them away. You're not going to need them for this project. Now the other thing to note is that the U-bolt itself, you cannot, without difficulty, slide it up on the hub itself. So it's easy if you come from the inside to the outside, over the threadings. It's the threadings that make it too tight, and so it's a lot easier if you do that way. Could you get it up? Sure, but we're just going to go from the inside out. Alright, we're going to put 1 on each side, and then another one on each side, so. And they may not want to stay there. They're not. Alright. So, we'll just continue to work it. Alright, so this is the orientation. So, rear, front. The tab side of the yoke needs to face the left-hand side. And this portion is going to the front because that's what's going to control the actual tilt mechanism with the motor. So the easiest way is come in from the front. Notice we still have all of the front mechanisms and panels removed in order to make this easiest. So you come in, we're going to get 1 U-bolt set in. There's the second set. Okay. And very carefully we're just going to do quick hand tighten. I'm going to do this side, you will do that side, alright?
Okay. Uh-oh.
You don't lose the nuts. Okay, go ahead and start on that one. You don't have to hold on to them. Now, nice and straight, stand up tall. Do this. Yoke clicks. Okay, keep holding.
Okay.
Alright, so what we've done is we've adjusted the yoke in order so that the tab on this side, when it's in this position, are 2 standing fully upright, and the tab pushes up on the yoke and makes it click. So now we go ahead and tighten it down. You see, this is why we wanted the top portion open and accessible. Alright, we're going to finish tightening this up. We'll be right back. Stick around. Alright, welcome back. Alright, so one of the things, as I always like to tell you, as we go do a little bit more hands-on, so when you are putting on the U-bolts, what you want to do first, this is not in Kevin's instructions, but we'll go back and look at putting in there. You want to put the outside edge U-bolts on first. You're going to want to finger tighten those down. And you're going to raise, make sure, so you need a partner helping, which is Y Cadet Connors here. You're going to make sure he's standing completely upright. You want to hear the yoke click, or push up on the limit switch. Okay, it just clicked. So when it goes up like that, then you want to tighten down these bolts. The problem is if you do both sets of the inner U-bolts at the same time, unless you have a really deep, tall socket, a standard crescent wrench is going to be challenging trying to get through those with the first set of bolts. So the easiest way, and the way Connor and I did it off screen, is we took out the first set of U-bolts, did the outer edges first, got those in place, got it nice and tight. Then we put in the second set of U-bolts, got those nice and tight. Alright, so now what we're going to do is we're going to demonstrate, because he's still fairly loose, because he's now top heavy. Alright, so we're going to pitch him forward. Ready?
Ready.
Okay. And there he clicks right there at the bottom limit. And he moves back up. And there's the top limit. Okay? So the other thing is we're running, lower him down. We're running the extended booster legs with the booster covers will go on there. So that gives us an extra 5/8 of an inch clearance. So you can see right here is where it would get problematic, where the bottom ring of the frame and the skirt would start to potentially hit the front edge of your battery box. Now, an easy way to get around this, I did test this, now we're on camera. If you have it in the cannon leg position, you would either need to shift your battery box about quarter to a half an inch backwards towards the rear of the foot. That means it's not necessarily going to be perfectly lined up with your foot box or your foot shell. I don't think anyone's really going to notice, but if you slide it back about a quarter of an inch to half an inch, you may get that clearance that you need. Your other option is you can grind out a small groove and kind of make this smooth and just take away just enough so you can get the clearance in there and a clearance off of the skirt. But since ours is already painted up and we have the extended booster covers, we're just going to go ahead and run the extended. Our next droid will get down to the cannon leg length. Or if we have significant paint repairs, I may get froggy and go back and do it that way. Alright, so you got a hold of him? Alright, keep holding. Now, one of the other things that's important, and Connor and I discovered this while we were doing it, if you've noticed, our center leg lift was fully raised. Now, when it's fully raised, the drawer hinge covers hit the yoke when he's in three-leg position. So when you try to pitch him forward, you can't get low enough down because these covers are pushing up against it and you get resistance. So that's another note. So what we did is we didn't lower it all the way, we didn't raise it all the way. It's literally maybe 1.5 inches just below this lip. All right? Okay, so hold on to him. Alright, so now we are getting the tilt motor. Alright, so as you can see, that spins. Okay, so that's going to go all the way off. Okay, alright, Connor, what we're going to do is we're going to rotate R2 around so everybody can see this.
Okay.
Okay, so let's get these out of the way. Now he may try to dance on us while we do this. Okay. Alright, so we're going to go turn that way. Okay. Get out of the way. Alright. Okay. Grab him. He's trying to dance. Okay. Just have to hold the foot.
Okay.
Alright, so now it's easier for everyone to see. So the first thing we have is hold on to his leg so he doesn't try to dance, okay? So we have our tilt mechanism. So we just literally unscrew this. This. We're just going to make sure, no, just a smidge too tight on those. So we'll have to enlarge that. Now let's check holes on this. Alright, we've already enlarged those ones, so those are good. Okay, so you have two small screws. They have small bushing on them, so it allows it to go through the aluminum. So what we're going to do is we're going to use the middle holes. So there's 3 holes, 1, 2, 3. We're going to use the middle one. And we're going to go to the frontmost post. So slide that in. Let's get the cables dressed up. Ah. Go with the middle one. Finger tight. And of course it wants to hesitate just a little bit. Just couldn't get enough tension on the one hand. And in case you're wondering, that was a 1/8 hex bit that I used. Alright, we are going to enlarge these holes ever so slightly. Let's figure out what size. Right in there. And now spin this down. Slides inside the block. That one on. Let the bolt right in there. Okay. There we go. See? Now he won't move at all, will he?
Nope. No.
Totally stable. Like, can't get him to go either direction, can he?
Nope.
No.
Thanks
So that's a good thing. Okay.
I think the only problem is just wheels.
Well, yeah, he can slide around on his wheels. So now he's rock solid, right?
Yep.
Okay. Just leave the nuts in there.
Okay.
Just get the aluminum shavings out of the way. I have a nasty habit of stabbing my hands with them. Alright. Let me get my wire stripper. Let us see.
I feel like this leg is shifted It's not really parallel with the bottom.
Now you say something. Alright, we'll be right back. Alright, welcome back to some more of This Old Empire. As you can see, we've got all the legs attached to the COM-8 32 frame, or the COM-8 38 COM-8 CSR frame. Wow, tongue twister. We also have the Kevin Holme 323 center lift mechanism attached, and it's got the yoke, and we've gone ahead and attached the pivot screw on. And the last thing we need to do, if you remember, we took off the top of the COM-8, so we just need to reattach that. Let's get the motor housing, top plate, and we've got the right side screwdriver. Yep, do. All right. Alright, there we go. Alright, so this is our tilt motor. Alright, so here's its cables, positive and negative. You reverse it, it goes up. You reverse it, it comes down. Alright, so we need to make it go down. Now, we've got all of the Kevin Holme 323 system locked in there on the sides. Now, one of the things that's really kind of important to note, I don't know if you heard Connor comment, probably even get rid of it in the notes, but he commented that, hey, this leg doesn't look like it's perfectly vertical. And he was absolutely correct. It was off by about 1.5 degrees. So while you're going back and forth, you know, I'll say this, the easy thing was get the yoke to the places that we wanted it so that it moved the shoulder hubs so that I had the full range of motion that I needed. And then I had actually disconnected the linkages on the side that go down the leg. And by doing so, I was able to basically pivot the leg up and down, or pivot the yoke, or move the leg back and forth in order to make sure I had full range of motion. And then I was able to reach into the leg and adjust that bracket piece up or down until it lined up so I got maximum range of motion. So we're back to a full 18 degrees, actually it's like 18.3. But you know what? Government work, that's where this comes in handy. As you can see, this is going nowhere. I can't shake, I'm shaking the whole frame. This box is not going anywhere. This motor mount's not going anywhere. The yoke's not going anywhere. This thing is rock solid. It's freaking cool. So what we're gonna do is, well, now's the moment we've all been waiting for. I have a power supply here, and we're just gonna connect it up real quick. As such. And I have to hold on to it because this thing, so I'm running 12 volts at it with 18 amps. Nowhere near, but this is coming through a bench power supply, so I can control the voltage. There we go. He's back at 18 degrees. And that really wants to tilt, as you can see. So what we're going to do, and that was full range of motion, and it is just shy of the full upper portion up here. So it's driving all of it. That's fantastic. What I was watching is here's the switch that we wanted to keep track of and not have it go too far and crush the switch, because it absolutely could do that. Alright, so what I'm doing that you can't see off camera is, rather than mess with the leads right here, I just switched it on the power supply so I can bring it back. Battery box there. There you have it. It's all the way back where it's supposed to be. Pretty freaking cool. What can I say? Amazing. Amazing. So, very, very powerful motor. This was, again, running at 12 volts. As you saw, that was pretty doggone quick. When you heard it starting to bog down, that's because it was running into my wood and the foam frame. So, no real concerns. We could run it at 5 volts. I'm quite sure it would run just fine. Without any of the resistance, it would go a lot smoother. But I think 12 volts is ideal for it. Nowhere near the 18 amps. Like I said, I'm using a computer bench power supply that has two 12 volt 18 amps, a minus 12 at 1 amp, a 5 volt at 22 amps, 3.3 volts at 17 amps, and of course the COM-8. Alright, what else? What have we not done? Oh, yes. So the wonderful cables are still hanging outside the legs. I'm just going to route this around the back so it's out of the way. Alright, so yes, the cables. Let me get something to poke with. Always have a good tool to leverage stuff. Alright, so there's no ends on this, so this will just slide right through the tube. I did take a brush head to the Dremel. Let me show you what it looks like. Just one of the stainless steel brush heads. One of these little deals. I just ran that through with the Dremel. Went through this side and then back that side. Just kind of polished it up, smoothed out the inner portions of the trace from when Kevin drilled it. Just trying to get rid of any burrs or anything of that nature. The other thing that I did is on the plastic housings for the Hall sensor. It had a full-on tab on each side. So I very carefully with my Dremel took it down to the exact same size, you know, the height of, or the width of the actual plugs themselves. So took down this portion and this portion, let's see, as much as you can. Took down right here, beveled the edges, and in doing so, I can now slide it right through the leg. There we are. As long as I don't get a cut on everything. Okay. Now let's run this other one through. Alright, so what I'm doing right now is I'm using the braiding. It doesn't like it if it gets caked. Here we go. That side is in. Okay, that comes to the back. And we will repeat on this side. So again, had it sanded down, clean through. Now my Dremel bit was not able to go in all the way, so I went in from this direction as far as I could go, and this direction as far as I can go. If you've noticed, I use the extended one in order to be able to do more fine details. That allows me to get a lot closer to it. So I'm actually very, very happy about this. Didn't have to take anything away from Kevin's hubs, which means they maintain all of their strength and rigidity. Then I also have a means of easily detaching my legs. So that was always kind of one of the things I wanted to do. All I'm doing right now is just trying to dress it up inside the hole a little bit, make it so as neat as possible. All right. Okay. Didn't have to use my poker. So you're probably also noticing I'm back to wearing my gloves again. That's because since I've been doing some cleanup, my hands are dirty and it's leaving grease and residue and nastiness on my parts, and I'm trying to get it back to having all nice, clean, white, ready to go. So, yeah. I think the next thing we need to do is, let's see. Oh, we need to attach the center leg. Yeah, that's the next part. Okay. So let's get our center leg, center foot. Here we go. Put this down real quick. All right, let's make sure we. All right, so we'll have to lift it up. So I'll need to get a partner back to do that, so we'll lift it up and then set it underneath, and what we'll do is we'll lower the lift down, and then it should line up, and then just put the screws right in, and then pull it back up, and it should go inside. Now, one of the things that Kevin had warned me about, set down that right there, is the inside of the skirt. So I'm gonna take some, go offline. Before a bit, let's get some material. All right, so we got some white craft foam. It's fairly close in color. This is just what you can get at normal craft store. Comes in 8.5 by 11 sheet. So what we're gonna do is we're gonna measure the inside of the skirt where the foot shell goes, and we're going to do. I haven't quite figured out the dimensions yet, but the intent is on the front of the skirt and the back of the skirt, on the inside where the foot goes. Since it's going to go up and down, we want to put a little of this on there so it has some padding. So we're probably going to use some Bond's glue to hold it in place against the aluminum, and then we'll probably go up the whole area on the inside of the skirt, just so that as the foot comes up, it's going to pivot, the ankle pivots easily. So this ankle's pivoting, and as this goes in, you don't want it to bang on the inside of the skirt, which is going to give it natural weathering. But we'd like to kind of keep the paint job nice for as long as possible, and do our own weathering style and let it slowly weather on its own. So I'm going to go ahead and measure the inside of the skirt, cut this to fit the inside. We'll get some bonds on there, and I'll compress it on there, and then I'll bring the camera underneath so you can see exactly what I did, and then that will make it easy to get. At that point, I will just lean this back, we'll get the center foot underneath, and then we'll go ahead and attach it, and then you'll be able to see the center foot go up and down. We'll do it independently of the legs, and yeah, I think we're good to go. Stick around, I'll be right back. Alright, so welcome back. I said bonds, I meant to say barge. Barge is the all-purpose cement that I use. Used this when we made our Falcon. It's fantastic stuff. Nasty, really nasty. Make sure you wear the appropriate breathing apparatuses. Alright, now what I'm going to do is I'm going to show you exactly what I did. So you can see, get the cable free. So you can see down here, right here, is where I put the barge as well as the piece of fabric foam. So I ended up using a 7 1/4. It's 7 1/4 inches wide and 2 inches high. I did another one here on the front facing as well. So that's just on there, is now curing. We'll bring this back up. Ooh, I'm sure everyone's got a little bit of nausea there. All that motion. Apologies, but sometimes it's worthwhile seeing some of the coolness that we're doing. Alright, so you can see we got that in there. That will be set probably here in the next 20-30 minutes. So what we're going to do is get our center foot. Alright. And now we're just going to lean the droid back. Just like that. That gets it just inside there. A little tight. As such. Actually, before we do that, we got to take the screws out. That would have been funny as we lower it down and go, oh my goodness, I can't get to the screws that are in there. That would have been non-helpful. Okay. Just repeat the process. And actually, we didn't even have to tilt it. We just had to make sure we had a good maneuver space in there. Alright, and you can see now our center foot is sitting underneath. Sorry, just notice we have a next spot that just got loose from all the movement, so pardon me while I tighten this up. loose bolt. It's not. It's good. All right. So what we're gonna do. We've got our lift right there. There's the cables. We're gonna move this down to 5 volts. So otherwise, it's way too fast and will take off on me. Let's get this closer. Now, I do not remember which way is which on this, so you will have to bear with me. Get that closer. Here. Connection there. There we go. That should lower it down. So let's slide underneath. Alright. It is literally right on top of it. Now, reach down in, get my big old meat head out of the way so you guys can see. Now, so the way I have this set up is designed so that the motors can run. The reason they're 1/4 inch off the ground is so that these motors and everything aren't really touching. That looks attached. So anyway, train of thought, lost it. So these are barely just off the ground so they can free turn, so I can test power settings with R2 or the droid and not have to worry about him taking off and having to run around. So I can sit there and run power and go, okay, it's going slow, it's going fast, it's not. Left motor, right motor. Just one of the reasons it's a 1/4 inch. That way it's just got a little bit more flexibility. And it keeps all the strain and weight off of it. Puts it up on the skirt so it takes the pressure off the shoulders. Alright, so let's see if it goes down any further. It should not. Okay, so it hit its physical stop with the limit switch. And then I am going to reverse the wires since I don't have my Sabertooth hooked up yet. I do have it, Sabertooth 2x32. So right now the easiest just be for just play with the actual power. So now this should pull up inside. Alright, we're just going to stop with that. It's not that it can't, it's running against the foam on the inside that it's fighting. But good news is it's actually bringing it up just like it's supposed to. So that is really cool. May have to take him off the wood block just to see it all go. So I'm pretty stoked about this. This is pretty cool. So let's have the foot come back down. There we have it, fully extended. And if we were to do this, he would separate out, maintain balance. So remember, I said I was doing this at 5 volts on the side motors. That is strictly so that it is not hauling up and down and I have a means to control it. It will definitely go faster. You know what the heck, let's just see what it looks like. How bad it's going to pull that foam. And it's going to pop that foam. That's right. Alright, here we go. Yep, it's completely ran into the foam. any farther. So, not a problem. Not a problem at all. Very cool. Glad to see it. That is a solid connection. Let's have that raise up just a smidge. There we go. Alright, so yeah, that is the COM-8 frame with a Kevin Holme 232 conversion. I'm pretty freaking stoked. So the next thing, we'll be going ahead and getting our actually, know what we're going to do? We'll be back in a few minutes. We're going to take this off, and we're going to go ahead and have it go work on the saber tooth, and that way it should control everything together. And the next step, we'll be putting on our booster covers and leg housings and all of that. So, pretty excited. This is really coming together. We'll see you on the next episode of This Old Empire.